So test is Tuesday on 1.1 to 1.6. I'm actually going to come back to the first page because this was stuff that we reviewed for the quiz. You had it on the quiz, so you should be good with this stuff, but I'll come back to the first page. All right, let's find our domain for B. Domain is the x values. So what would our domain be here? Joy, what do you think? Negative infinity to positive infinity. Awesome. Our arrow is pointing forever in the left direction and forever in the right direction. So negative infinity to positive infinity. Next, let's find our range. Range is our y values. Remember, for domain and range, we always start from small to high. So here we start at the bottom. What's our smallest y value that our graph goes to? Bless you. Negative infinity. And what's our largest y value? 4. And since 4 is a closed circle, it gets a bracket. So for domain, you want to start from left to right. For range, you start from bottom to top. Because it's always smallest to largest. Now let's do our intervals of increasing, decreasing, and constant. Well, just like how we read from left to right, we read a graph going from left to right. So if I started at the left, would I be walking uphill or downhill? Uphill, so I'm increasing here. Increasing from where to where? Awesome. We're increasing to here, which is at 0. Remember, increasing, decreasing, and constant are always x values. Bless you. So we're increasing from negative infinity to 0. So then at 0, we start decreasing. We're walking downhill to where? To infinity. Awesome. So even though our arrow points down, it's going to the right. We're looking at x values. So x to the right goes to infinity. Are we constant anywhere on our graph here? No. So constant would be none. So increasing, decreasing, and constant are always x values, and they are always just parentheses. So last thing we're going to do is graph our piecewise function. So we've got 2 pieces here, so our graph is going to have 2 pieces. What's the first number I want to plug in to graph my first piece here? -1. We always start with the number that it gives us. So we're going to plug in -1 into our x. So we've got 3 minus -1, which would be 4. So our point is -1 comma 4. At -1, since that was one of our key numbers that it tells us, is it an open or closed circle? Closed, because it's less than or equal to. That equal to means that it's a closed circle. So we're going to go on our graph to the left, -1, and up 4. Put a closed circle. Now we need some direction for this line that we have here. What's another point that we could plug in? Awesome. Anything that is less than -1. So -2 works. So 3 minus -2 would be 5. So our point here would be -2 comma 5. The second point just gives us direction. It's not an open or closed circle. The only open or closed circles that we need to focus on are the 2 numbers that are given, our key numbers there. Second one just gives us direction. So we go to the left, -2, and up 5. And then we just connect our dots with a straight line. Any questions on that piece? All right, let's graph our second one. What's the number we plug in first for our second piece of our graph here? 1. So we're going to start by plugging in 1. We have 1 squared plus 1, which would be 2. Does this point get an open or closed circle? Open, because it is a greater than sign. There's no equal to, so it's an open circle. So we go to the right one and up 2. Put an open circle. Now we need some direction for our graph here. What's the shape of this graph going to be? A parabola. But remember, it could be any part of the parabola. I think some people got confused on the quiz. You can have a parabola that goes from here to here and just be this little portion of the parabola, which almost looks like a straight line. It's not always going to show that curve. You may have a parabola that goes from here to here where you've got that curve to it. But sometimes it may just be like the upper part of the parabola where you don't really see like the U shape. So it depends on which piece of your parabola that you have. So for our next point here, what number should we plug in? 2. Anything that is greater than 1. So let's plug in 2. So 2 squared plus 1 would be 4 plus 1, which is 5. Again, the second piece just gives us direction. It is not a defined open or closed circle. It's just on our line. So we're going to go to the right 2 and up 5. If you want to, plot another point, because you know that this is a parabola, you know it's got some type of curve a little bit, so we're going to test another point. We can plug in 3. So we've got 3 squared plus 1, which would be 10. So I'm going to go to the right 3 and up 10. Should be there. So now that we have our 3 points, we can draw our parabola. So it's not a lot of curve that we have going on here because it's just kind of the upper piece of the parabola. So this would be our graph. You start at your key points. So we want to start our graph here. Just start here. Start at your defined open or closed circle, your key points here. The other points just give you direction of your line. If we had a middle piece of our graph here, if we had something in the middle, a third part, it'll have a start and a stop. So then we just connect those two. It doesn't get an arrow when you have a start and a stop. So let's look at the second page. I'm going to do number 3b. So to determine if a function's even, odd, or neither, we want to plug in a number and its opposite. If we get the same number, that means that they are even. If we get opposite answers, then it is odd. And if we get totally different answers, then it would be neither. So a good number to plug in would be 2 and -2, but depending on what the question looks like, you can plug in whatever you want. So I'm going to plug in 2 and -2 for B. So we got to be careful. That negative is on the outside of the x squared. So I have -2 squared minus 2. 2 squared would be 4. Since that negative is on the outside, it would be -4 minus 2, which is -6. Next, let's plug in -2. So that negative again is on the outside. So we have -2 squared. -2 squared would be 4. The negative on the outside makes it -4 minus 2, which would be -6. So what do we think? Even, odd, or neither? Even. We got the same answer, so our answer would be even. All right. Let's look at number 5 next. So here we have a combination function where we're going to add, subtract, multiply, whatever it asks us for our two functions. I'm going to not worry about f plus g of x. Let's just say this question only asks us for f plus g of 3. So we could add our two functions together and then plug in 3, or you can plug in 3 and then add them together. Doesn't matter which way you want to do it. I'm going to add them together. So f is x squared plus 3 plus g is the square root of 7 minus x. Now here we can't simplify, but we don't need to because we just have to plug in 3. So f plus g, when it gives you the number, we got to plug in that number. So we're going to plug in 3 into our x's. So 3 squared plus 3 plus the square root of 7 minus 3. This would be 9 plus 3 plus 7 minus 3 would be the square root of 4. 9 plus 3 is 12 plus square root of 4 is what? 2. 12 plus 2 is 14. So we would have gotten the same answer if we plugged it in separately and then just added them together. So if I plugged in the x's from the beginning, plugged in 3 into the x's in the beginning, so we had 9 plus 3 would be 12. And then this would be the square root of 7 minus 3 is 4, which is 2. 12 plus 2 would be 14. So either way, you can plug it in, then add them together, because it tells us to add here. Or you can add your two functions together and then plug it in. Awesome. Let's go to the next page. It asks us to find f of g of 0. So here we're going to plug 0 in. So first let's find f of g. Or we could find f of g first and then plug 0 in. Or we could find g of 0, take that answer, and then plug it into f. I'll show you both ways. Which one is on the inside here? G. So we're going to take g and plug it into f. So let's find, I'll work it out here for f of g. So we have the cubed root of x cubed plus 1 minus 1. So I just took g and plugged it into the x in f. Can we simplify this? What simplifies?
The ones cancel.
The ones cancel. 1 minus 1 would just be 0. So we have the cubed root of x cubed. Can this simplify? Yeah, the cubed root and the cubed cancels. So f of g would just be x. F of g of x would just be x. Now if we found f of g of 0, we take 0 and plug it in. What's f of g of 0? 0. So we could do it that way where we find f of g first, then plug it in, or the other way to do it, so I'll call it way number 2, is we can take 0, plug it into the inside one. So if we plug 0 into the x here, it'd be 0 cubed plus 1. What's 0 cubed plus 1? 0 plus 1 would just be 1. So g of 0 is 1. Then we take that answer and plug it into the x in f. So we start with the inside, then do the outside one. So f of 1 now would be the cubed root of 1 minus 1, which is the cubed root of 0, which is just 0. So you end up with the same answer. You could do it either way. So you can find f of g of x first, then plug in your 0, or you can plug in the 0 into g, get that answer, and then plug that answer into f. Next, let's find f of g in number 7. So f of g of x. Remember, it can be written this way, or it could be written as f of g of x. These mean the same thing. They're just two different ways of writing the same thing. So if you see one way or the other on the test, you know that they're asking for the same thing. So what's on the inside here? G. So we're going to take g and plug it into f. So here we have 1 over x to the third power. We can simplify this. When we have a fraction raised to an exponent, the top gets raised to the third power and the bottom gets raised to the third power. Or if you want to work it out, it's 1 over x times 1 over x times 1 over x 3 times. So 1 times 1 times 1 would be 1, and x times x times x is x to the third power. So that would be f of g of x. Next, let's find the domain. So to find the domain of a composition function, we want to find two things: the domain of the inside and the domain of the whole new thing. So starting with the domain of G, let's find our domain of G. Now we have to look for two things when we're checking for domain: if we have square roots and if we have fractions. Do we have a square root or fraction here? Yes. What can we not have in the denominator of a fraction? What can our denominator not be? Cindy, what can our denominator not be? 0. So we'd say our denominator does not equal 0. So for our domain of G, when we check the inside, we have to say x does not equal 0. If we put that on a number line, it'd be all the numbers except 0. Second thing we want to check is the domain of the whole new function. So our new function was this. F of g of x, we said, was 1 over x to the third power. Well, we have a fraction again here. What can I not have in the denominator of a fraction? Cindy, what can we not have in the denominator of a fraction? 0. So our denominator cannot be equal to 0. So again here, x cubed does not equal 0, which would just be x does not equal 0. So same thing. X does not equal 0, so it'd be every number except 0. How would I write this in interval notation? Bless you. If we're talking about every number except 0. Olivia. Not negative infinity to positive infinity. We have to say every number except 0. So negative infinity to what? To 0. With a bracket or parentheses? Are we including 0? No, so it has to be a parentheses. And then where would we start again? 0 and to infinity. So if we say every number except 0, this is how we would write it. From negative infinity to 0, and then from 0 to infinity. With domain, there's two things we need to look out for: if we have square roots and if we have fractions. So if we have a square root, what can we not have under the square root? A negative. So we'd set whatever is under our square root greater than or equal to 0 to find the domain. If we have a fraction, what can we not have in the denominator of a fraction? What can it not be equal to? 0. So then we'd set whatever is in our denominator not equal to 0. Now with square roots, this works for even index square roots. So if we have a square root or the 4th root or the 6th root, you can't have a negative. But if we have the cubed root, let's say, our domain is all real numbers. So cubed root, our domain could be negative numbers. We can take the cubed root of -8. That would give us -2. So just keep that in mind for your tests. You want to look out for square roots. If it has an even index, it can't be a negative under your square root or under your 4th root. It can be a negative under a cubed root. All right, on the next page, let's look at 8. We want to find the following given the 2 points. So first, let's find our distance. Our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. I'm going to label my points, x1, y1, x2, y2, and then plug them in. So 8 minus 0 squared plus 4 minus negative 4 squared. So we get 8 squared plus, what's 4 minus negative 4? Emma, what's 4 minus negative 4? Eight. This turns into a plus, so 4 plus 4 would be 8. So 8 squared. So we get the square root of 64 plus 64, which would be the square root of 128. Can I leave my answer like this? No. We always want to simplify our radical. So how would we simplify this? What are 2 factors of 128? Rihanna, give me 1 factor of 128. 2. So 2 goes into 128 64 times. What are 2 factors of 64? 8 times 8. We could stop here because we see we have a pair of 8s. So the square root of 128 would be 8 square root 2. So that would be our distance. Thank you. Any questions here? So for distance formula, you're just plugging it into the formula and simplifying your square root. Make sure you know how to simplify a square root. Next, let's find the midpoint. So our midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. So we're just finding the average of the x's and the average of the y's. So this would be 0 plus 8 over 2, comma, negative 4 plus 4 over 2. So 8 over 2 and 0 over 2. Which would simplify to what? 4, comma, 0. Awesome. And then our slope formula is y2 minus y1 over x2 minus x1. Just because I ran out of space, I'm not going to find the slope here, but make sure you know your slope formula, your midpoint formula, and your distance formula for the test. All right, let's do 9. Determine if the lines are parallel, perpendicular, or neither. So we're going to do 9a. So if our lines are parallel, what do we know about the slopes? They're the same slope. If our lines are perpendicular, what do we know about the slopes? Opposite reciprocals. So in A, how can I find the slope here? What would I need to do?
Isolate y.
Awesome. We want to isolate y. We want to put it into y equals mx plus b form. So that way I can clearly identify what my slope is. So I'm going to subtract the 5x to move it to the other side. So we get y is equal to negative 5x plus 9. So what's our slope here? Negative 5. Now let's do the same thing for the second line. Again, I'm going to put it in y equals mx plus b form. So I'm going to add 1 to move it to the other side. So y equals 1 over 5x plus 1. What's our slope here? 1 over 5. So these are not the same slope, so it's not parallel. Are they opposite reciprocals? Yeah. One's positive, one's negative. And then if we flip 5, it would become 1 over 5. So these would be perpendicular. All right, for number 10, we're going to find the average rate of change of the function over the given interval. So here it gives us x1 and x2. We want to find y1 and y2. How could I find y1? What would I need to do here? Cassandra, what would we do here? How do we find y1? So we're going to plug in -2 because that's our x1 into the equation. So we have 5 times -2 to the 4th power minus 2 times -2 plus 3. -2 to the 4th power would be 16. And 5 times 16 would be 80. Yeah. Plus 4 plus 3. So this would be 87. So our y1 is 87. How would we find y2? David, what would we do to find y2? Plug in the 1. So we have 5 times 1 to the 4th power minus 2 times 1 plus 3. So 1 to the 4th power would be 1 times 5 is 5 minus 2 plus 3. So this would be 6. Now once I have my y1 and my y2, for rate of change, that is the slope. So we're going to use our slope formula. y2 minus y1 over x2 minus x1. So we're just going to plug everything in. So 6 minus 87 over 1 minus -2. We get -81 over 3. Can I simplify? What's -81 divided by 3? -27. Awesome. All right, 11, let's find the zeros of the function. So we want to make f of x 0, and we're going to solve. So here we have 4 terms. How do we solve with 4 terms, or how do we factor with 4 terms? Grouping. We want to group the first 2 and group the second 2. Then we take the GCF out of each group. What's our GCF out of our first group here? 2x squared. Awesome. When we divide out the 2x squared, we're left with x minus 5. What's the GCF from our second group? Perfect, -3. We have to take out a -3, not a +3, because we need our insides to be exactly the same. So when I divide out a -3, I'm left with x minus 5. So grouping only works if your insides are exactly the same, because the insides are going to go together to be one factor, x minus 5. The outsides are going to go together to be another factor. So that would be 2x squared minus 3. Now this is still equal to 0. Once we factor it by grouping, we can set both of the factors equal to 0 and solve. So 2x squared minus 3 equals 0, and x minus 5 equals 0. So in the first one, I'm going to add 3. So 2x squared is equal to 3. What would we do next? Divide by 2. X squared equals 3 over 2. Then what? Square root. So x is equal to what? Plus or minus square root 3 over 2. Now for the second one, x is equal to 5. We don't have to do anything there. I'm okay with you leaving the fraction inside the square root. We haven't rationalized yet, so I'm okay with this. Later on in the year when we start rationalizing things, we'll have to simplify this more, but this is fine. Any questions here? So if you have 4 terms, you want to factor by grouping. Let's do E. So I'm going to change f of x to be 0. And from here we want to factor. How would we factor this?
Take out the 2x.
Awesome. We want to take out the GCF. Since our GCF has an x in it, we're going to leave it in our equation. So 0 is equal to 2x is our GCF. Everything's going to get divided by 2x. So we're left with x squared plus 3x minus 28. Yeah. Now from here we can factor nicely. What are two factors of negative 28 that add to 3?
Negative 7 and positive 4.
Positive 7 and negative 4. So this would factor into x plus 7, x minus 4, and 2x. From here we'd set each piece equal to 0. So 2x equals 0, x plus 7 equals 0, and x minus 4 equals 0. So x is equal to 0, x is equal to negative 7, and x is equal to 4. Make sure you guys know how to factor. Yes?
Can you show me how to do the first part where it goes from 2x times 2x cubed to 2x parentheses?
Yeah. So here we see that they're all divisible by 2.
Okay.
So we want to divide out a 2. And they all have an x in it. So we're going to divide out a 2x. So 2 divided by 2 would go away. If we have x to the third power, so if we have 3 x's and we take 1 away, we're left with x squared. 6 divided by 2 was 3. If we have 2 x's and take 1 away, we're just left with x, so 3x. And then negative 56 divided by 2 is negative 28. And then the x's cancel. So let's look at 13. We're going to find the inverse algebraically. So what's the first step we want to do to find the inverse?
Change the x to y, or the f of x to x, and then the x to y.
Awesome. We're going to flip our x and y. So f of x becomes x and x becomes y. I'm going to do it on the side over here. So we have x is equal to y minus 2 squared plus 1. Now what would we do next?
Subtract the 1.
Subtract the 1. We want to undo everything on the right side to get y all by itself. So we have x minus 1 is equal to y minus 2 squared. What would we do next? Square root. We want to square root that squared to get rid of it. So we're going to square root both sides. So it cancels out with the squared. So we have the square root of x minus 1 is equal to y minus 2. And what's the last step? Or the next step, I guess. Add 2. And we can't add 2 to the minus 1 because the 2 is not under the square root. So we have the square root of x minus 1 plus 2. So the 2 just stays outside. And that's equal to y. What's the very last step that we do? We got to name the inverse. So we have to put that little inverse symbol. So y negative 1 is equal to the square root of x minus 1 plus 2.